Hi, you're listening to the NewSpace India podcast, a bi weekly talk show that exclusively brings insights from the Indian space activities ecosystem. I'm your host, Narayan, the co founder of India's first space focused think tank, Spaceport Sarabhai. Guests on the NewSpace India podcast help you understand space activities related macro and micro trends within India in all aspects, including space history, local industry, space science, technology evolution, law and policy, art, and more. The NewSpace India podcast is supported by Dassault Systems, a global leader in providing businesses and people with collaborative virtual environments to enable sustainable innovations. Dassault Systems Solutions supports startups, small and medium-scale enterprises, and original equipment manufacturers in developing disruptive solutions for space launchers and satellites. Hi, and welcome to yet another episode of the NewSpace India podcast. Today we have Tushar here, who leads Manastu Space propulsion company that is based in India, one of the only propulsion companies that I know apart from Bellatrix, I guess, that are innovating and have been innovating for the last decade or so in India. So, Tushar, thank you so much for taking the time again, and welcome to the show.
Thank you, Nayan. It's good to meet you and good to talk to you. And it's always fascinating to share our journey, what we have gone through, and what are we planning to do. Thank you for your inviting.
So before we get into like Manastu and everything else, I know that you also worked in DRDO, and your colleague also, I guess, worked in somewhere in the government or so on. You need a lot of motivation to quit a government job in India to start a company as is. So, what led to the creation of Manastu? Was it job frustration, or was it, just the opportunity that you saw that you wanted to build a company for? Or was it a mix of everything else? What is the story behind the start of Manastu?
Startup Manastu, it's combination of actually 2-3 things. So when I was studying in IIT Bombay, the few things were clear that either I didn't want to work for MNC, and either I'll work. So options remained, I'll either work for government or start my own startup. So through campus, got into DRDO. And the DRDO was, I would say, very interesting experience. I will not label anything else. There I got to do a lot of things. What is happening in the overall defense ecosystem, and how India is approaching, and where are the gaps that are there, and more importantly, how not to do the defense and some of the high tech developments also. So got to learn a very interesting sets of things, and whatever I had plans of doing while joining the DRDO didn't work out the way I was planning to, because leaving many of the good private opportunities and other lucrative jobs, joining a DRDO was whole motivation was to do some amazing tech, and that took a hit with some of the decisions that happened. So, and simultaneously the uh, space was growing, and we could see clearly there are a lot of interesting things were happening. It was around 2016-17 also. So then took a plunge of leaving the job and starting Manastu Space. For me, it was straightforward, quite a straightforward, for a simple reason that it was not about whatever the job security was and everything is that comes with a government job, just one part of it. For me, the biggest problem was uh, you know going on the deathbed and trying, and with having that regret of not trying, of always what I was capable of, and what I always wanted to do. So that regret, not doing something was, and not doing what I always wanted to do, was weighing more than having a job security. So I said, this is the best time to get into. Let's take a plunge and let's see where it goes. And being an IIT Bombay alumni, it gives a lot of safety nets to try if things worked out. So we took a jump with the head first, and things are been working out in very interesting ways that we'll discuss in coming.
Right. And when you wanted to take the plunge and start the company, was it that the IIT Bombay had a entrepreneurship cell that offered you support, and that led to some sort of a gateway into finding some, earnings or seed money to begin with, or how did you actually make a plunge? Because, of course, you either need to have or come from a very rich family to do something in space, where the family gives you seed money, or sometimes do something in software like we are doing, for example, where we have very little investment and purely it's code, and you can write code just eating 2 meals a day and build a product on top of that. Otherwise, you will need to have people who believe in your ideas and start investing in you so that you can spend that money to build that hardware. So, how did you come up with the seed funding, for example, for these ideas to then mature?
So interestingly for us, finding a fund was actually, was, of course, some money is important to start running, but somehow for Manastu, things have happened with the time that whenever we needed a money, we found a way to get the money through competition, through grants or something. So we didn't wait for investor to come and give the money and then continue the process. So we took a plunge and started the working, and somehow every time we faced an issue, we got the money that we required and we found the support that was required. So I believe that passion of doing something that you always love will always lead to you to find a way to solve a problem, be that of a money, be that of a finding infrastructure, a mentor, or team member, teammate, co-founder, any of those things. If you really really want to do those things, you will find those things. So that has been the case. So for us, IIT Bombay was for sure a big help. We started working with the support in the IIT Bombay labs using IIT Bombay facilities, and professors helped us to give some of the access to some few lab facilities there, so we could start our little hardware development, and uh, not just the hardware development, as well as the mentoring also, how to go ahead in terms of technology, as well as and another. Then with a slowly in year and a half in the development, then we got a shell got invested in us in a very small amount, but more than the amount they started helping us from the R&D side, as well as the lab facilities, some of the material that consumable that we wanted to buy, which are the expensive materials. So through that, we found a way to get the work done. So if someone is not giving money, we'll ask them for support in kind. If someone is not able to support in kind, we'll ask them to connect in, make some connections that we can help us in finding some alternative to that. So that has been the case every time we face a problem, and that's how we found a way. And that's how the Manastu took us started. Very slowly, we started in our lab with almost minimum support in terms of financial background, and as well as any initial investor, and then things took on organically as and when required.
When you look at the whole propulsion game today, it's changed drastically over the last 10 years or so, I guess. A lot of the propulsion around the world has been hydrazine oriented and essentially very toxic. I know that even if some few milligrams or whatever micrograms of these kinds of things enter your body, you can die as quickly as, like, I don't know, a few days or something like that, or even a few hours. So these are very difficult technologies that have taken quite a long time to transition. And from what you guys are trying to do with green propulsion and so on, this is a kind of a game changer in propulsion technology in general. And essentially, this has been evolved in the last 10 years or so in many different parts around the world. So before we get into what Manastu does itself in green propulsion, I would love for you to kind of give a brief about how propulsion has evolved in terms of propellants and toxicity and carcinogenics and so on, and how this new era of propulsion is either saving time or saving effort, or removing health hazards or so on.
Yeah, very interesting, very good question actually. To be frank, space propulsion did not change much till last 10 years. I'll say 10 to 15 years or so. The government was, especially the NASA led support effort, and few other companies were doing some finding an alternatives and trying few combinations, but the really efforts really took off since 2010 or so, 2000, I'll say 6 or so, and then big way since the European Union blacklisted it, the hydrazine under the REACH program, and they gave the industry 10 years. So that was 2011 10 years is 2021, but because of COVID, those timelines have a little shifted. So industry got the hint basically that it's at high time that we need to go move out of this hydrazine. To give you an idea, the scale of a problem is that hydrazine is 2 times toxic than the gas that led Bhopal gas tragedy, which is methyl isocyanate, and it is as toxic as some of the cyanides that are there. So we know what happens when there is an accident, when there is a leakage, when the vapors. Vapors are also toxic. When you inhale, when you are working for long duration, when you inhale those fumes, that is also carcinogenic. So in all, on the name of space development, using space for the betterment of Earth and all the treaties we signed, we are killing a people on a ground slow death. That is, that are the behind the scene unsung heroes who are dying unknowingly, knowingly over the period of last so many decades or so, I must say. And the obvious question comes in, then why were there not been much efforts before last say, 10, 15 years ago? For a simple reason, it works well. The hydrogen people are comfortable in terms of how it performs, how it behaves under different conditions, what are the properties, the technologies around it, was well laid out. So that's why that inertia that always the space industry always had, because the space has been done by the large corporates, NASA's and ISRO's of the world. And since last 15 years or so, now this commercialization has started in a big way. Now the people are talking about, saving money, saving a cost in the operational cost, and not afford to uh, have that expensive hydrogen system, because synthesizing hydrogen is also expensive process. Then transporting it is also expensive because it's extremely toxic, and handling it, filling it into the satellite, that operation cost around 3 days, 1 days before, and you need to clear out the area. Then you need fill the operation of filling it into the satellite, and then the next day you need to keep that area empty because of the fumes which are also toxic. So everything adds up into the cost of operation. As more and more businesses are coming, the more and more the economy is playing a big role in space development. People are looking out for a green propulsion system which will be a the less toxic, much less toxic than the hydrazine. The B, uh, at least minimum as efficient as hydrazine, or best, the good will be more efficient than that, and preferably cheaper option in terms of cost of one unit system, cheaper option. But the toxicity, the performance, and the cost are the three main driving factors. So something that will not kill people while handling, while transportation, you need a less safety compared to hydrazine. It comes under a broad green propulsion umbrella, basically.
Excellent, and thank you for that kind of a very brief, very non-technical but still very relevant explanation of the whole thing. And from an Indian perspective here, I know that ISRO still uses some of the older technology with hydrazine and others for their space propulsion requirements, given that they're all very well tested in orbit and have been used in many satellites, and probably they don't want to they don't want to disturb any of that at the moment. Can you give a rundown on, except you guys pushing this front on green propulsion and so on, is there any specific government lab in India, either in ISRO or DRDO or others, who've actually tried to make any of investments in this front or have done any experiments relevant? Or is it that you guys are really looking at it as pioneers trying to do this thing, while people within ISRO or DRDO are then able to use technology from you guys, for example?
ISRO, the way ISRO functions is little different than the businesses, and for them, getting 100% success is more important than making a profit or revenue or do the cost cutting, because the way the ISRO is structured, the way the country looks at it. So the job of ISRO is to take as minimum risk as possible and get the mission successful. And the fact that we don't have a alternative in India which is affordable currently, that can go today into the satellite, ISRO doesn't have an alternative but to go ahead with the hydrazine or hydrazine-based systems, be that for satellite maintenance, station keeping, maneuvering, as well as the orbit transfer also. So bipropellant, monopropellant combined put together. So that, even saying, having said that, ISRO is trying its own hands on some of the developments on the green propulsion, HAN based, hydroxyl ammonium based, nitrate based system internally. So they are trying that options. There are a lot of work that needs to be done. There's some small efforts that been going on in ISRO that, as far as we are aware of, and we believe that we have a very good opportunity to not just pioneerize development has been started in ISRO. What we have believe is that we have option to make it be a pioneer in in terms of commercializing it first time in India. In fact, we don't care about commercialization in first time in India. We want to be a global player. So we would love ISRO to use our system once we develop it successfully, and our propulsion system powering Indian satellites, ISRO satellite. That will be definitely a dream, and that was definitely one of the demand or the request with in space, that that Indian body that is set up to interface with the startups and industry. That can we do that in the coming future once we do the flight testing. Coming to the DRDO defense side of the aspect, the defense is currently the hydrazine, and they have funded our startup to develop an alternative, so green propulsion system. So through us, their green propulsion systems are green propulsion efforts are being taken forward.
Right. And that's again very interesting that you mentioned about both these efforts. From a scale perspective, there are companies that are trying to do these kinds of propulsion technologies from very small satellites. I know somebody who's also trying to develop propulsion for, I don't know, satellites that are like 200 grams, 300 grams, right? To people who are looking at, 6-ton satellites with all electric and things like that, right? So the scale can be very broad with respect to the size of the satellite, the kind of maneuvers, which orbit they want to go into, what kind of life plan they have. Would they want to also deorbit the satellite using some of the propulsion capability they have, or there are many things that go into these things, right? So, from Manastu's perspective, is there a particular sweet spot that you think that you are going to hit, that maybe today there are satellites that are 10 to 30 kilograms, which are in the hundreds, that are being launched every month, and some of them are today coming up with like 100 to 300 kilogram kind of satellites that are OneWeb or Starlink or many others like that, or even some of the bigger Earth observation satellites. And there's a tiny bit of satellites that go into geo orbit nowadays, right? So what is the scale in which your propulsion systems would work, and what would be the targets for the kind of operators that you would want to then work with?
Yes, absolutely. So it's a huge market. You see the diversity in terms of the satellite types and what are the applications that they are been, in terms of the orbit where they will be, in terms of application, in terms of payload, in terms of maneuver, in terms of trajectory. It's overwhelming. So we came, so after a lot of studies and the best fit of our technology, we believe that the sweet spot is somewhere between 100 to 300 kg satellites, and we are okay. We serve the smaller satellites like 80 kgs, 90 kgs also for sure. This is not hard and fast bound, but we believe that is another very interesting market uh, that is coming up. So two types of satellite market we believe is going to create a biggest disruptions are the satellites of around say 5 kgs to 7 kgs. The under the small CubeSat or little over the CubeSat market, and the small satellites which are around 150 kg is a sweet spot satellite, because 150 kg satellites are satellites which are big enough to carry a good amount of payload, but small enough to be launched in hundreds and thousands of numbers, be that of a high definition imaging, radar based satellites. Then of course internet satellites are there, and a lot of infrastructure people are building on in the inside in the space to serve the satellites in the space, combination of those things. So we believe that is one very interesting market: high definition imaging, real time videos, and internet, and as well as the small satellites which are like 5 kgs, 7 kgs, where you launch it in the flocks and figure it out phenomena that, so that you can using a high definition high resolution camera, you can zoom into one particular location or target some particular phenomena in great detail. So combination of those type of satellites working in sync will be a game changer, and that is what we believe will be a very interesting case. So that's why we are also, nothing stops us to go serve satellites which are around say 50 kgs, or satellites are of around 300 400 kgs, as long as the thrust that required by them matches with us, and the duration in which we are qualifying our propulsion system is in the same range of their qualification as well as their time duration. So so that is currently a plan.
Nice. And from the perspective of the technology itself, there's probably two elements of this. I'm no propulsion expert, but from a logical standpoint, at least when I look at it, you kind of need to engineer the propellant itself, the kind of the green propellant that you will probably look at, and you need to engineer the device or the thruster itself to be able to fire the propellant that you will be then be using it, right? So they have to work together in that sense. So from the approach that you guys are taking, is it like a parallelized approach that you kind of work on both of them and mix and match, and then look at firing it and testing it out? And let's say on top of that, how good is like the private sector talent pool and infrastructure and supplier availability for some of the components and the tests to be conducted to realize all of these things?
Yes, two big questions actually to combine. So let me answer the first question, where what is the approach we took and what are the systems that are there in the process of development. You exactly pointed out two very key innovations: is the propellant and the the thruster part. There is actually one very interesting component that is there, that is actually a secret ingredient, uh, is the catalyst actually. Catalyst is, you can imagine, like a spark plug in the car that starts the combustion. So catalyst is something similar that sits inside this thruster or engine, and starts the combustion when the propellant or the fuel is injected on it. So rather than having spark plug, we have a catalyst which sits there, and whenever the fuel comes, it starts the ignition combustion, and the thrust is generated. Whenever the flow is stopped, the thrust stops. So we took a sort of a parallel approach, for a simple reason that, uh, there were when we started, we had a risk of whether the propellant will be stable or no. We started with a plan A, plan B to ensure that it is stable, so that if plan A doesn't work out, which is the best case scenario, plan B will be the second best case scenario with little bit of penalty and little lower performance. So, and then even in that plan B, whether it makes sense to build a system from customer point of view in terms of economics, as well as the USP point of view to the satellite manufacturer, that made sense. So we took that decision. So we started with this plan A, plan B for propellant because it was new. Other two aspects, the thruster and the catalyst has been figured out by some of the companies worldwide. So we know it can be done. It's just a matter of time that we do it with R&D, experimentation and iterative testing. And then the third part is the thruster. So we know it works. So it's a matter of time we re-engineer the internal design in terms of injection pattern, how the combustion happens, what are the lengths, the dimensions, etc. of the engine. We are figuring out that combustion in a more detail. So all things doing parallel is the approach that we took, with a plan A, plan B of each subsystem. It does, if A doesn't work out, what will be the B, and what will be the penalty, and what is the risk associated with, so everything on that line. Coming to your second question about the talent infrastructure, oh, India needs a lot of work on that side, especially infrastructure point. So we have a good talent. We have a really, really good talent. We have seen people from very simple universities, not very known universities in the local towns, coming and doing some which has never left their home city and coming and staying with us here in Mumbai in the midst of this metropolitans and one of the most active cities in the world, and doing some fabulous job. And that includes convincing ISRO DRDO scientists about the work that we are doing, and then getting up, convincing them in the different reviews. So we believe there is a lot of potential. There is a lot of talent. Yes, there is a gap between trained talent. I will say that will be good if we do a lot of support, lot of students project, so that we get a talent when it is out of university, that it has that experience of building a space technology. We would love, as an industry, we would love to have that talent for sure. Coming to infrastructure, we are really need to work really hard to establish the infrastructure, b the ecosystem of uh, as you mentioned about the suppliers of a different components like walls, ceilings and everything, which will which has who have experience of building a their component in the space grade manner as well, if not space grade, at least the defense grade manner or something on those lines. So we need a lot of work on that. Another major work that India needs to do is on the material side, material and the manufacturing side. We still have a decent manufacturing facilities in the country, decent, thanks to a lot of you know the setup that ISRO has taken a time to train a lot of companies, ISRO, DRDO, defense, PSUs, and all of them put together. They have trained a lot of companies to do manufacturing, but we are really bad in terms of materials, original material development, original materials, manufacturing, that high temperature materials. We need a huge investment into those things, creating an infrastructure so that we can accelerate that material development. Currently that is one of the problems that we face. The catalyst is the material that we are developing, which is a secret sauce, is one of the most cutting edge materials that are available. And in terms of the temperature it needs to survive, in terms of the operating condition, pressure, the thermal cycles it has to go through, and it is really hard to quickly do a turnaround of one design, one synthesis, and then getting the material done, and then testing it inside the engine, and then figuring out how it works, and then doing that repetitive cycle. Lack of infrastructure increases that cycle like anything, in terms of analysis, in terms of testing, in terms of synthesis. So we need a lot of work in terms of setting up the infrastructure. And to be frank, the all the energy transition that is happening, green revolution, uh, uh, is being led by the development in the materials. If you see carbon capture technologies, processing of that carbon capture, be that of a solar panel, be that of a battery is probably the most important. And we, India, is missing that bus of being a vital part because of not ability non ability to innovate in the material development. And I think we have that. With the last 4 years of development, we have developed that capabilities and know-how of a material development, ultra high temperature materials, variety of materials, from development from the scratch to the commercial level. So we are developing that capabilities, infrastructure, slowly in-house, but we need a whole set of ecosystems who invest money in R&D, infrastructure, and take initiative to do different materials and build a whole ecosystem around.
Yeah, that's a very comprehensive answer. Thank you for that. I think it's also interesting as to how all of this is developing when companies like yourself are taking a very product oriented approach, because most often the vendors that work with ISRO are very like service oriented approach, where they don't really invest in a lot of IP development, but they invest in a lot of infrastructure that can produce for ISRO, and the de-risking of the IP itself is done by ISRO in the process, right? So that's a interesting outcome, and it's also great that you're able to leverage some of the ISRO vendors themselves, I guess, in the process of doing all of this. But let's say from the adoption perspective on how do you actually test this in space, you can do a lot of ground-based testing in thermovacs, and do all sorts of tests of cycling and firing and all of these things. But at the end of the day, of course, adoption only comes when you're able to put this on a satellite and say this is fired in space and this is now working and it's gone through so many cycles, or you're able to fire it so many times or so on, right? So how do you see this working for you guys? Will it be that you will be directly flying on a customer's satellites, or do you work with somebody like an IIT Bombay, who is where you come from as well, that they just put some of your thrusters and say, we'll fly the satellite and we'll qualify the thruster for you on board one of these satellites? Or are you also, let's say, putting it on one of ISRO's or DRDO satellites and saying, okay, they will qualify the thruster in the process of them putting it on one of their satellites?
Yeah. So answering your earlier part of question, or rather adding to the earlier part of comment, look, as a startup, we don't have an option but to innovate. And rather, I'll put it other way around. Whenever someone is doing innovation, that is a startup. So otherwise, we would have been a routine business. And taking the risk and innovating comes naturally. And it's always a game of risk versus reward. People are okay to take a low risk, the manufacturing for ISRO, to the design that ISRO has provided or the DRDO has provided, the missiles and all those things, and take a very small share of the whole product, or the economy, versus someone who takes a risk and build a system around it and then qualifies it and put into the production and take a big chunk of the profit, the margin in that whole product. So you can compare, like, think of a iPhone, Apple versus Foxconn. Do you want to become a Foxconn or do you want to become Apple of any particular product is what you need to decide on. And as a startup, for us, it comes naturally, for we people, it comes naturally to take the risk and focus on the larger chunk, because we don't have any baggage of having already infrastructure legacy and having no that some companies have a legal mindset of that we are good in those things, we'll not enter into those. So risk comes naturally, so is the reward proportionately. So that's why we had to, and we are here because last generation did not take that risk of innovating. So someone had to take a risk, and we can't point a finger that no one is doing. So we took a plunge and we decided, let's do this thing and let's establish the ecosystem. So at least next generation of entrepreneurs will benefit from the decision that we took. So coming to your second question, yes, definitely the flight testing is the next critical milestone for us also. And for that we are working on three potential options currently. One is we are talking to the companies who are building a satellite, who builds a satellite and for a customer, and then launch it and do that operations in terms of tracking and everything for a customer payload. We are talking to such a customers who will do flight testing for us. Second thing is we are in touch with ISRO and DRDOs that we can we put our satellite as piggy bank on our propulsion system as a piggy bank on their satellite. And the third is the best case will be the some of the companies who are building a new satellite. They build a satellite and they want to test their platform. So we build our satellite and we build our propulsion system. They build a satellite, so they take care of a share of a cost of building a satellite and launching that much weight, and we take a share of a cost of building our propulsion system and launching it into the launching cost of that much of weight. So we are evaluating all the three options. Every option has its pros and cons. If we go with a dedicated satellite that has already been proven, then the cost will be much higher than the third option where we share with the new partner who is building a satellite. It's just that the new satellite means uncertainty into their platform also, because our system is new, their system is new. We will not be able to know exactly who, if it fails, why it has failed. But the second option sounds very comfortable, putting it onto ISRO DRDO satellites. It's just that it comes with its own timeline delays and plans. So as a startup, we can't rely on all those options, that uncertainty for long. So we are evaluating those three options, and in terms of as the the time progresses, as the funding supports, the financial supports, and as we have more confidence of our system, will finalize one or the two options maybe, and then take a and then go ahead and then finally choose one of them, so to test the system into the space. So idea is by the mid of next year, get the launch it our system by the end of this year 2022, and by the mid of next year have it completely tested, say 6 months of mission life. That is currently a target. It depends on the resources as well as how technology matures, but these are the internal targets for our system.
Good luck to you and the team, for that. I think it's very interesting, and there's great potential for companies like you to start exporting some technology from India rather than simply trying to work within the country to supply for the market within. From, let's say, the perspective of the kind of support that you can receive to give you kind of a nudge from within the space program or even outside the space program, there are, of course, many ways in which the Americans or Europeans also help some of these companies by either helping them fund some of these technologies or fly some of these technologies in one way or the other. And there are initiatives and frameworks that are available for them to engage to doing all of this. And whatever you are doing is something that you are doing within your own power, and are trying to figure out ways in which you can progress despite having any of these kinds of frameworks available. If you would give any suggestions as to something could be done for companies like you to be getting that nudge, what would that wish list look like?
Yeah, actually, it's a interesting question, and I think there's a lot of discussion been going on. How can government bodies, especially support ISRO can support startups in terms of multiple ways. As you mentioned, the financial funding the project, then helping them in the process of developing a product or technology or the service, and then third, maybe help them uh, bringing that technology to the maturity level and then helping them to make it mature technology, be that of a satellite, be that of a launch vehicle or the propulsion system or any of the onboard hardware you're developing, like new processor, new antennas or something. These are these are the areas you need a lot of hand holding, a lot of support from, and many of the problems that are there that startups are planning to solve has been already solved by organizations like ISRO. So with their help, the journey can become, focusing on the solving the most important problems rather than figuring out the peripheral things that ISRO has already, with crores of rupees and a lot of years of hard work, has already solved. So definitely support in this way, uh, starting with the funds, maybe supporting in terms of like the ESA has the ESA big incubation program, the NASA has this funding, the overall government has the small business funding initiatives program. So any of those kind of program in a big way in India, where they can encourage the early stage of a startup, will be a definitely on the first list. First item. Second item, supporting them in development of the technology in terms of figuring out that things that has been already figured out, helping them with the infrastructure, helping them with the mentoring, helping them with the do's and don'ts of a space industry. It's like, say, even like small things like using a clean room effectively, transportation of some of the flight components from one location to another location, so that in the process they don't get damaged, and then figuring out ways to handle those equipments. Those are very small things which ISRO over the times, making some mistakes, figuring out, doing a lot of experimentation, has figured out. So they can do that part in very short duration. Those can be translated to the startup. So That will be the second handholding uh, in terms of product development, as well as the establishing a process of product development. And the third, and definitely, will be the guidance in terms of like a lot of the director level scientists, people who have the experience of directing the projects, big scale project, how the project development happens, what are the pros and what are the risks, how the risk has to associate, how the cost goes on into the development, how to plan the infrastructure development as well as the people management. So that guideline through the people who have retired scientists and all those things coming forward and actively helping startups, they are already doing it. And if they do it in a more way, that will definitely helpful a lot of be helpful for startups. Another vertical that government and even overall ISRO can help is to making a clear policy line guidelines and helping startups to figure it out what does that exactly policy means and how can we leverage that policy to create a world class product, world class service, and rather than hampering our own startups and services in India. So the policy wise framework, the rules and regulation norms of those things, helping the startups and setting them in the first place, and then helping the startups to fulfill those regulations will be a very important support the government, including the ISROs and other bodies, can do to help a startup. So these are will be roughly top level four or five items on my list. And actually, we have a lot more list. Like retired people of ISRO scientists are like a gem, and if they can, we get access to those people, will be a very game changer. Another will be the lot of lot of vendors and lot of supplier that ISRO has developed with that over the period of time. If ISRO make an access the list of those people accessible, and some of the designs that ISRO has done will reduce a lot of work for us. So that will comes under, you can put it roughly under handholding. But these are the top levels help wish list per se that we can expect for startups to have it. But nonetheless, it's a challenge. So solving the challenge is a part of a story. So it's just that we want to create a world class product, and without world class support, it takes a lot of time, investment, and to create that world class product. So by the time the rest of the world would have gone much ahead, till the time we figure it out how these things happen. So to make it to give our own startup a competitive edge, we need to create this infrastructure system process around the startups and the whole ecosystem.
That's a very comprehensive list and very nice, actually, explanation to what are all the things that can be exploited within the country to support companies at the end. And from your own story, actually, given that you are coming from this IIT Bombay ecosystem, a very prestigious institute, and coming from that kind of a background, as well as having connections to, being an alumni of DRDO or so on, I guess that also adds a lot of value in, and also probably some credibility in terms of approaching these institutions for help as well. If you weren't from any of these institutions, not any big name institution or of that nature, would you have been at the same place that you are today, or would the journey have been a lot more difficult, as from your experience so far?
Interesting question. Let me think. For sure, journey would have been different. Maybe difficult, if you ask me personally. Mm, for a simple reason, uh, you know, forget about the infrastructure and contact and any other support. The biggest support that biggest help support the IT, the tag of IT Bombay gives is that when is that you have that safety net that if this doesn't work out, you have multiple more options. When you join the first, what makes IITs little different or valuable is that it's not about the infrastructure or it's not about this anything else. It's just that the mindset. When the person joins an IIT on the first day, that they've been told that they're good, they're the topmost, they're the cream of the nation and so called, and that goes into the mind. Okay, you can do a lot of things. It's just the sky is the limit. What you can do, and we have so many people doing those things that So you get that confidence, when someone tells you again and again and again and that you're good, you're cream, and etc and etc. So that instills that confidence. So now that baseline is clear, that even if this doesn't work out, you have a lot of options, frees up a lot of space in your head to think about what next. And then that what next ability is to take a risk related to building a startups or venturing into something unknowns on your own, or and in the process you will find a support. Having said that, everyone has his own journey, and then if you really want to get something done, be that of a big name of like IITs, IIMs, or any other things, I think it matters just set 5% in 100% of journey, or even maybe a less than that, except the fact that some of the investors look for IIT IIM tax, but that we also, everyone face the same problems, same challenges. Apart from that, we need to same convince the investor, convince the customers to buy our system, negotiate with the vendor, and vendor will have its own problem to deliver things. So that don't make our any life easier. So I'll say it would have been definitely different, maybe little difficult. Maybe we would have had to find some more different ways to get the work done. But I think we might, if anyone wants to get it done, they can find a way to get it done. It's just a matter of time. Maybe in terms of, say, if it took say 3 years to get something done, they might take say 4 years or 4.5 years to get those things done. So don't let anyone tell you that because you're not from the top universities, so-called top universities, you can't do something, or it's not possible, or it's very difficult. It's as equal. It's difficult for us as then for any other people, and anyone can do what they want to do if they really want to do. As bad as say breathing, then you will eventually do it.
From a perspective of customers, from your own product, for example, right? Does it get easier to ride on somebody's brand like an ISRO brand, which has a very good international reputation, that they do reliable stuff and they have lots of flight heritage, and coming from India is borrowing a little bit of ISRO's prestige in the international market? And is that useful while talking to international customers, or is there a little bit of skepticism saying, should we go in and work with an Indian company and buy technology from there? So what is the kind of reception that you get as a state of the art technology provider coming from India when it comes to international markets?
Actually, we we do ride on ISRO's good work over the last so many years, and that helps. That helps. ISRO has set up a brand image, that India is a place where you get things done, especially in the case of a space, at very affordable price, and they work reliably. So the cost and the reliability are probably the two most important factors that are playing a role in making the new space economy that has been today and going forward for next say 50 years, 100 years down the line. So the cost, reliability, the performance, so those 3 4 parameters. So we definitely ride on the ISRO's good work over the years, and the value, that the image of Indian space program that they have established in the eyes of all the foreign companies. If you comparatively, if you are selling a defense product, then people are little more skeptical than say you're selling a space product. As long as you have all the certification and the fact that you're in India, they're very 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 much open to discuss and see how things goes on. So having said that, as I mentioned, the cost is important factor, and few countries who will India who who can afford that costs are probably say India, China, and few other countries maybe. And India and China are the two big spacefaring nations. uh, India sits at a very interesting junction of socio-economical, geopolitically point of view. That India has a very good relations with multiple of the countries, uh, major countries, major spacefaring nations, especially Europe, US, Australia, Japan, and Russia also. So because of that, uh, the people have that understanding. Okay, India means we can rely on the India because of geopolitical situation. So that gives us a lot of edge over many of the other people, because we are competing at the cost, and of course technology is the cutting edge, and people trust India overall development wise. And now people, for long people were trusting the services of India, like software services. Now the shift is happening slowly, steadily, long way to go, but still shift is happening, that people are relying on Indian hardware also, slowly. And that you can see in terms of rise of lot of investment into the deep tech startups that is coming up. Numbers are very small, but they are rising in a very good way, in a very interesting positive way. And probably maybe 5 years, 7 years to 10 years down the line, we'll start seeing uh, IPOs and SPACs of Indian deep tech startups also. So that shows that a lot of investment from outside India coming into the Indian startups, space startups, signing MOUs, collaborating with a lot of foreign companies, is a sign of that trust building up. We are also closely working with multiple of the foreign companies from France, Germany, the Japan also, and figuring out how ways we can do it, and then signing contracts with some of the companies. So things are changing rapidly, and we have the advantage in terms of cost, geopolitics, as well as the reliability of because of ISRO. So that definitely helps.
So, what are the challenges looking like today and for the next, let's say, couple of years for you guys? Is it mostly fundraising to make sure that you have enough runway, or is it finding opportunities that can then, allow you to test out different scale of thrusters, or it's a combination of everything there?
Uh, I will say challenges are many. It's just that we are figuring out ways to solve those challenges. And I will say the milestones maybe as a term rather than challenges. So milestone will be to raise funds that we are currently raising quickly, and finish that flight testing as soon as possible. Start delivering the system to the customer, because when we started our startup journey, we didn't want to do the business, or we don't want to develop a startup in a way we are just burning the investor money. So that's why we started a small, with a one small part of a whole system, and making it a big to start with, and then building on top of that is what we were building. And so that's why we spent a lot of time to get the paying customers, and through Indian defense we got that. So we always want to build a sustainable business out of it, rather than startup which will raise 4 or 5 rounds of money and still have no customer or no revenue. So we didn't want to do that. So that's why we took this thing. So target is to the trust that has been shown by the current customers and the customers that we are talking to, fulfilling that trust and start delivering on to their trust is the first milestone. I'll say second after fundraising is the first milestone currently. That is customer reliable reliably testing it into the space is the second milestone. And then we have a lot of interesting technologies in pipeline, a lot on that we want to build on top of the current propulsion system. We Our technology can make something like a combination of electric as well as the green propulsion system in using one propellant. That is the next development in line. So combination of electric plus chemical in one system is what we are developing on. So uh, two things in one go, in one system, so you get the best of the both the world. That is what another is what next system. Along with that, we are also working on planning how can we support the customer from end to end. So start of life, where we give them a propulsion system, to in-place refueling as a service to extend the life. And then once we have a platform which will can do a in-space refueling, which we believe is another major growth, major development that is going to happen, is the in-space services, be that of a refueling, be that of a uh, as a bus, a space tug, or be that of a debris removal service like what Astroscale is happening. So refueling is what we are targeting, so that we can support customer from end to end. So there are 4 5, I'll say, a very interesting technology that are lined up after this thing. So delivering on the current promises and then going ahead and building on to top of the current technology to build an amazing product is are the main challenges for next 3 or 4 years that we are currently working on preparing up, gearing up as we go.
Great. I think that's actually a very interesting overview of all the things that you have planned in the next couple of years, and it's very comprehensive as well. Good luck to the team, and I'm hoping that you guys and many of the other new space companies that are all starting out to get into this more of delivering to customers, maturing their products, and then eventually entering the market with a buzz are able to succeed and then create a wave of some of these companies from India who are actually going to be starting to compete internationally and grab some of the market share. I think that is the only way that we can basically coerce the government in one way or the other to support the sector more, because at the end of the day people need to see some evidence of success coming out, and then I guess only then I see the system giving a better push that there is some evidence that this sector is about to grow.
Yes, a very valid point, because is we are in the for last still this year and maybe next year we are in the nascent stage where we are just many of the startups are raising money. In a year or two, it's a time that we start delivering to the promises that we made it to all the investors, customers, and all of them, so that we can build on those promises and raise more money. We are raising startups are raising in tens of millions of dollars in that order. So now the target is, can we convince investors to so that they can start investing in say 15s or hundreds of millions of dollars going forward, and that will come only when we start delivering to the customers, to the investors, and not just to wait for the government to support. I believe all the startups can support each other and create that formidable combination that individual startup can be when we come and join hands forces together. So from our side, we are always willing to help, support, or any way help any other startups that require. And we believe if even all those current startups are there, if they join together, then will be a very very interesting force to reckon with that we have currently. And then so this is the way forward, and definitely government today or tomorrow will take a notice. Government is taking a notice in a big way, and a lot of initiatives are the sign of it. It's just that we need lot more work can be done, lot more. There is a lot of margin to do that work development from government side. But as we speak, slowly, steadily, that change is happening. So it's very welcome change. But we startup needs to come together, help each other, and build an ecosystem rather than competing with each other.
Yeah, absolutely. And again, very well put. Thank you so much for spending the time in recording this episode. It's been very educative for me as well to see how a company like you matures in a country like India, for example, getting out. And I'm sure that the listeners will also find it very interesting. Is there a kind of people who are interested in contacting you either for jobs or even for advice? What is the best way of reaching you? And if there's also kind of people who you want to reach out to you, what would those kind of people would be?
Yeah, reaching out to me, very simple option. You can LinkedIn is the most common way, or the you can email me my first name dot last name at the rate of manastuspace.com. So Tushar dot jadhav at the rate manastuspace.com is a simple email address, or you can email on the website also, that comes to me itself. So anyway, any one of the option is okay. What kind of people? So look, well, the business is all about the people. So we are always look out for the people who are good in the technology, who are good in selling, who are good in the business development, who are good in marketing, or who are passionate about the hardware, who are passionate about some of the softwares, writing the code. We are always open and always looking out, always hiring for this kind of a people. So even if you have a inclination to sell, or inclination to build, an inclination to solve one problem and stick with a problem for long duration, then we are the place to do so. At Manastu, you will get all the freedom to try new things, succeed. So when someone joins on the first day, we just tell them two things: just don't break our trust, and don't get killed. Apart from that, they have all the freedoms to discuss with each other, try new ideas, as long as we are doing the work that we do, and and we and then make a promise on the day one itself that if you stay with us for long, we'll take care of you. If you want to do another job because of some XYZ reason, we will be the first one to help you find another job. If you want to go do higher studies, we will be write the best recommendation letter in the world that you possibly can think of. And if you stay with us, we'll help you. We'll take care of you the best possible we can. So we make it very clear upfront that this is a place for you to try new things, grow, and make the most out of it and enjoy the process. So any of the people who are listening, who are interested in this journey, always feel free to contact us, message us, email us anyway.
Fascinating and very well put again, Tushar. Thank you so much for taking the time, and good luck to the team again.
Thank you, Naren. Thank you, everybody. It's always fun to talk to you. Thank you so much.
Thank you for listening in to this episode of the NewSpace India podcast. If you enjoyed this conversation, please share this episode with anyone you believe will enjoy listening to it. You'll be able to find the NewSpace India podcast in any of the podcasting platforms that you may be using, including Apple, Google, Spotify, YouTube, and others. Do subscribe to the podcast in case you want to receive new episodes automatically. I'm grateful if you're able to leave a rating for the podcast, which will help others discover it. Thank you for listening in again, and the next episode will be out in the next 2 weeks as usual.